Welcome to our exploration of one of the most profound questions in modern cosmology. What was before the Big Bang? While we often think of the Big Bang as the start of everything, emerging theories suggest that there may be much more to the story. In this video, we will delve into the concept of the multiverse, examining how ideas like eternal inflation, string theory, and cyclic universes challenge our understanding of time and existence. Join us as we navigate the fascinating possibilities of different universes and their implications for our own, sparking a universe of questions along the way. 1. The Big Bang. A starting point, but not the beginning. The Big Bang theory is the prevailing explanation for the origin of our universe. It posits that around 13.8 billion years ago, the universe began as a singularity, a point of infinite density and temperature, and has been expanding ever since. However, this theory doesn't address what triggered the Big Bang or what existed before it. Some physicists argue that the Big Bang wasn't the absolute beginning but rather a transition from a prior state. This idea opens the door to theories like the multiverse, where our universe is just one of many. It's akin to imagining our universe as a chapter in a never-ending book. The story doesn't start with the first page we read. 2. The multiverse. A universe of possibilities. The multiverse theory suggests that our universe is one of countless others, each with its own physical laws and constants. These universes could exist in parallel, separated by dimensions we cannot perceive, or they could be part of an infinite cycle of cosmic birth and death. The concept of the multiverse isn't a single theory but a collection of ideas, including eternal inflation, string theory, and cyclic models. Each offers a unique perspective on what might have existed before the Big Bang. Imagine a vast ocean, with each droplet representing a different universe, each with its unique currents and tides. 3. Eternal inflation. Bubbles in the cosmic foam. One of the most popular multiverse theories is eternal inflation. According to this idea, the universe underwent a rapid expansion phase shortly after the Big Bang. In some regions, this inflation never stopped, creating bubble universes that continue to expand. Our universe might be one such bubble, floating in a vast ocean of other bubbles. This theory not only explains the uniformity of our universe but also suggests that other universes could have entirely different physical properties. It's like imagining each bubble as a separate world, each with its distinct atmosphere and life forms. 4. String theory and the multiverse. String theory, a framework that attempts to unify all fundamental forces, also supports the multiverse concept. It proposes that the universe is made up of tiny, vibrating strings, and the way these strings vibrate determines the laws of physics. In some versions of string theory, these vibrations could create multiple universes, each with its own unique set of physical laws. This idea is still speculative, but it provides a mathematical foundation for the multiverse. Think of it as a cosmic orchestra, where each string plays a different symphony, creating a multitude of universes. 5. Cyclic universes. The Big Bounce. Another intriguing idea is the cyclic universe model, often referred to as the Big Bounce. This theory suggests that the universe undergoes endless cycles of expansion and contraction. Instead of a singular Big Bang, there could have been a previous universe that collapsed into a singularity before bouncing back to create our current universe. This model avoids the need for a true beginning, suggesting that the cosmos has always existed in some form. It's like a cosmic heartbeat, with each beat representing a new universe emerging from the ashes of the old. 6. Quantum fluctuations. Something from nothing? Quantum mechanics introduces the idea that particles can spontaneously appear and disappear in a vacuum. Some physicists speculate that the entire universe could have emerged from a quantum fluctuation in a pre-existing void. This idea challenges the notion of nothingness, suggesting that even a vacuum is teeming with potential energy. If true, it could mean that our universe is just one of many quantum fluctuations in a larger multiverse. It's as if the universe arose from a cosmic dice roll, with each roll creating a new realm of existence. 7. Observational evidence. Clues in the cosmic microwave background. While the multiverse remains largely theoretical, some scientists have looked for evidence in the cosmic microwave background, CMB, the afterglow of the Big Bang. In 2011, researchers claimed to have found patterns in the CMB that could be signatures of collisions with other bubble universes. However, these findings are still debated, and more data is needed to confirm them. The James Webb Space Telescope, with its advanced capabilities, may provide further insights. These potential clues are akin to faint whispers from other worlds, hinting at a reality beyond our own. 8. Philosophical implications. Why does the multiverse matter? The multiverse isn't just a scientific concept, it has profound philosophical implications. If our universe is just one of many, it raises questions about the nature of reality, the uniqueness of life, and the fine-tuning of physical constants. Some argue that the multiverse could explain why our universe appears so finely tuned for life. In an infinite multiverse, it's statistically inevitable that at least one universe would have the right conditions. This line of thought is like pondering the vastness of a library, where among countless books, one tells our story. 9. Challenges and criticisms. Is the multiverse testable? One of the biggest challenges facing the multiverse theory is its testability. Since other universes, by definition, would be beyond our observable horizon, how can we ever prove their existence? Critics argue that the multiverse is more philosophy than science, as it currently lacks empirical evidence. However, proponents believe that indirect evidence, such as anomalies in the CMB or gravitational waves, could one day provide support. It's a scientific puzzle, where pieces remain elusive, yet the search continues. 10. Stephen Hawking's final theory. A simpler multiverse. In his final paper, Stephen Hawking proposed a simplified version of the multiverse. He suggested that the universe is finite and far less complex than previously thought. By applying string theory and holography, Hawking and his collaborator Thomas Hertog argued that the multiverse might consist of a smaller, more manageable number of universes. This theory, while still speculative, offers a more testable framework for understanding the cosmos. It's like simplifying a cosmic equation, making the multiverse more graspable. 11. The future of multiverse research. What's next? The search for evidence of the multiverse is ongoing. Upcoming missions like the European Space Agency's LISA, Laser Interferometer Space Antenna, aim to detect primordial gravitational waves, which could provide clues about the early universe and the existence of other universes. Additionally, advancements in quantum computing and string theory may offer new ways to explore these ideas. While the multiverse remains a mystery, it continues to inspire scientists and dreamers alike. The quest is akin to exploring uncharted territories, where each discovery unveils new horizons. 12. A universe of questions. The multiverse theory challenges our understanding of reality, pushing the boundaries of science and philosophy. While we may never know for certain what existed before the Big Bang, the pursuit of answers drives us to explore, question, and imagine. Whether through the lens of eternal inflation, string theory, or cyclic universes, the multiverse offers a glimpse into a cosmos far grander than our own. As we continue to probe the mysteries of the universe, one thing is clear: the journey is just as important as the destination.